Hello guys and welcome to my first tutorial. Many of you asked me to do a quick run through for the flower blossom compound that I did, and so yeah, here we go. I'm gonna segment this into two sections. The first one is going to be the point scatter to create the initial shape where all our instances will be put onto, and the second one is going to be the time offsets that we need to animate through our animation cache. So the first thing that I did was to animate a petal, since we don't have any deformers in Bifrost yet. So this is my animation from 1 to frame 100. Simple petal animation opening up. And this is our instance that we're going to put on all the points. So what we need to create our scatter is simple points with the construct points node. And as an input, we could start off by creating just one. Set it 1 unit on the x-axis, and let's get some scopes going. A little bit bigger. So yeah, here's our point. And the way that I thought about this was, if we have that point on the x and z plane, the only thing that we need to do is duplicate it and rotate it around the y-axis to create more points and make this a full circumference. So the way to do this is to create a for loop. And simply going to copy everything in here. The first point is going to be our start position, and for each loop we're going to rotate the point some degree, and by how much is easily figured out by dividing 360 by our maximum iterations. Need a float value here. And then we want to rotate the whole point around an axis. So we'll rotate by quaternion. The vector we're going to rotate is the incoming point. And the quaternion is going to consist of the y-axis and of the degrees of rotation that we have for each instance. So we multiply our fraction by the current index. This also needs to be a float. And then we're gonna convert this from degree to radians. And then take the axes, the y-axis, and the radians to give us the quaternion that we need. And these are all the points that we need. Flatten the array and construct. There we are. So if we change the iterations, we're getting more points in our circle. And that's everything we need to do for the position. We can also go ahead and hook up our instances so we can see what to do next. So I'm going to read the Alembic file. Here's my pedal. And since we have 100 frames of animation in here, we're going to read this 100 times, basically. So make another for loop. Run this 100 times. And then convert the current index to float value again. And put this into frame. And then we're gonna have 100 instances. Do we? No. Oh, to flatten the array. There we are. So that's the whole animation read in frame by frame. And this is the array that we're using for our instances. Great. Set instance geo. Take all of our meshes and our points. Oops. And then we can see that we do have the correct point positions. Let's make that radius a little bit bigger so we can see it. But there is no orientation yet. It's only point position in our data flow. So what we need to do is give all our points an orientation. And the way to do this is actually quite easy. We can set the orientation by using a normal and a tangent to orientation. And as a normal, we're going to use the y-axis. And as a tangent, we're going to use the point position, because the point position itself is a vector. If you think it in terms of drawing a line from that point to the origin. So we just take the point positions here as a tangent. The normal is set in the node, and out comes our orientation. So set point orientations. And voila. We might need to invert the tangent. So that's just a matter of multiplying it by -1. Now they're flipped. It's fine. And then let's create different layers of individual point circles. So these are our points. And we're going to just put that into another for loop, which will make up our layers. So I'll put that in here. I'll put the points again, and as an input we still need our radius. And since now we do have an array of arrays, we need to flatten that. And now the max iterations of that loop is going to determine how many layers we're going to create. And what we want to do is, for each layer, lerp the point positions towards the origin. So the way I did it was create a range, change range node, because our lerp, what's going to happen right after the point creation, is going to need a fraction or a weight. And for the first layer, we're not going to lerp it at all. So that's the first iteration, which is 0. And for the last iteration, we wanted to lerp it completely towards the origin, which should be a value of 1. So we need to normalize the values, essentially. So in the end, we want to have a value from 0 to 1. And our input values are going to start from 0 and end at our max iterations. So negative float node again, and pipe that into from end. And the value that's going to drive this is the current index. So now we can hook this up, and since this is going to lerp a vector, we need to first convert the scalar value into a vector 3. Oops. And there we are. I'll just disconnect our instances for now. We've created different layers that are lerped towards the middle. And the only thing left to do is to create some rotation offsets, for instance. So right after the lerp, we can take all the points for that layer and rotate them again around our y-axis at the origin. Since we already have that rotate angle to quaternion in place here, we can reuse it, take our points, rotate them by the y-axis at the origin, and by how much it's going to be a value that we want to put in times the current index. So each layer gets rotated a little bit more. So we multiply the current index. There's a float value already, so we'll take this one and pipe this out as layer offset, rotation offset. And now we can actually rotate these layers. And that's the first part, really. That's all there is to it. You can create more leaves, and if you want to play around and be fancy with it, you could also pipe out the range that we are lerping to. So you might not want the last ring to be as close to the middle as it is right now. So we could pipe this out as well and change this value, make it editable. And that's the first part of the tutorial. Hello and welcome back to the second part of the tutorial, where we're going to have a look at how to animate our instances and offset them layer by layer. There was one thing that I did wrong in the first half. It was when I created the layers, I hooked up the orientation like this, I think. But that's wrong. We had it right the first time. We want to keep our normal as y-axis, 0, 1, 0, and take the point positions as a tangent to make up orientations. And now everything is aligned correctly. What we also didn't do is rename this port to layer scale offset. Yeah. And we might also want to pipe out the max iterations on the point circle compound so we can adjust the number of petals. All right. Now, we do have all our 100 meshes from the Alembic file, and right now all our points are getting the same instance. And we can use the point instance ID parameter and set this onto our data stream, because right now we are missing the property. You can simply set it, set geoproperty, point instance ID, and make that a long. And then we hook up the timing. Since we're going to start at frame 1, we're going to load the first mesh of our Alembic caches, and so on and so on. If we scrub through the timeline to 100, we should get the full animation. That's the idea. So the frame as a float value, we need to convert this to long. Hook this up. And this should actually do it. We have an animation, yay. There's one missing frame. Maybe that's an offset, because the first index is 0, and the last is 99 instead of 100. But we can simply clamp this, so it's a maximum of 99, and then it's fine. Alright, so everything else that we need to hook up now is offsets to the frame time. And the way I did it was take our layers compound and introduce an animation offset for each layer. So I'm going to take the current index again. There's a float value of the current index, and multiply that by a value that we want to put out as a control again. So layer time offset. And since we're creating multiple points for this layer, we also need to duplicate this value as often. So I'm going to create a sequence array and get the array size of our point circle. That's how many time offset values we're going to create. Put this into start. It's not going to be any steps, and everything that comes out here is a time offset value for all the points on that layer. And I need to flatten them. And maybe create a property. Set geoproperty. Right after the point construction. And call this layer time offset. That's a float for now. And now that data can be retrieved somewhere down the line. We could use it here. So we get the geo property. Layer time offset. And then we're going to subtract it from the time. So time minus whatever the offset is. And yeah, if you increase the time offset, the inner layers are going to animate later. And that's the first step of making this interesting. The second thing you can add right here is a variation per petal. So we could create a random geo property. And that geo property needs to be let's say an offset of -5 up to +5 frames offset. I'm going to subtract that as well. And then it's just a matter of playing with the values and getting everything to look good. You might want to put those layers closer together with the radius. Alright, so what we can do next is scale our petals based on their layer, maybe, and also based on their animation time. Let's do this first. So we do have an animation cache from 0 to 99, and if we're working with scale, we might want to be in a range of 0 to 1, so we just normalize it with a range node. So it's 0 to 99, the output should be 0 to 1. And then we can make use of f-curves to get some more intricate control. scalar values, so we need to make that a vector 3. And set the point scale. So now, in the beginning of the animation, the petals are going to be scaled to 0, and at the end of the animation, the petals are going to be scaled to 1. And then we can just simply change it in the F-curve editor. Maybe like that. And also you can make different F-curves for different axes. So if you want to change the y-axis, for instance, we can hook it up like this. And then we might want to offset each individual layer and make that smaller towards the inner circles. And the best way to do this is to make another property, but we do have something in place already, which is the layer time offset. Just for the sake of demonstration, I'm going to use this layer time offset and subtract that from the scale. Since this is pretty high, I'm going to divide it first. By, let's say, 10, and subtract it from the scale. Oh, okay, that's still too much. Divide it some more. Yeah, there we go. So now the inner circles scale down considerably. And we could also tweak our initial setup a bit. Maybe like that. And yeah, that's our animation. You can add more layers to it. Maybe reduce the offset. And yeah, there we go. Have fun with it, guys.